Thank you. All right, so yeah, my name's Alice. I'm going to be talking about testing for accessibility. So just quickly, who I am. I work for Google, as per the t-shirt. I'm specifically a Chromium developer, so I work on the Chromium project. Specifically, I work on accessibility issues in Chromium. And I was born and raised in Melbourne. I went to Melbourne University. I'm now living in San Francisco after living in Sydney for quite a few years. So if anyone is wondering about my accent, it's kind of all over the place. That's how it is. All right, so talking about accessibility, and I'm going to go into a bit of a accessibility 101 just to give some background on what we're actually talking about when we talk about testing for accessibility. So this really great Wikipedia quote says, accessibility is the degree to which a product, service, device, or environment is available to as many people as possible. And what I like so much about this definition is that it doesn't mention ability or disability at all. So accessibility includes things like me standing outside in the bright sun looking at my mobile phone. It encompasses the fact that we are all functionally disabled from time to time in our lives, as well as many of us becoming permanently disabled at times in our lives. So for anyone who hasn't actually experienced inaccessibility or doesn't realize that they have, this is pretty much what it feels like. So if you've ever been using your favorite freedom-loving browser or your smartphone device that doesn't have Flash installed and come to look at a restaurant website, you just want to see if the menu has any gluten-free options, and you get this message, you can't come in, this site is not for you, you can't access this information, it's incredibly frustrating. So I think now that we all have smartphones, we can, and so we all have experienced this situation, we have a bit more insight into what it's actually like when something is inaccessible. So when we talk about accessibility, it's a fairly broad spectrum of things, and different users require different accommodations. So we have things like I mentioned, low vision users, which is, by the way, pretty much all of us once we get past about 40 or 50, and some of us earlier than that. So I have quite a few colleagues who are very short-sighted and can't read very, very small fonts. They have to make sure that they're able to resize their fonts, and it's quite frustrating when they can't. Hearing impaired or deaf, so I'm actually hearing impaired, so this is me, may need things like subtitles or text alternatives to audio-only speech outputs. Low motor ability, so this might be someone who's unable to use a mouse or unable to use a keyboard very well, are going to require certain accommodations that I'm going to go to in a bit more detail later on. Screen reader or braille display user, so this would be someone who may be completely blind, maybe just very poor vision such that they're actually unable to read but may be able to see some things, maybe a completely different ability spectrum. And voice control user, so someone who's completely unable to use a keyboard or mouse at all for whatever reason and needs to use voice control. So there's quite a wide range of things that we're talking about, but the good news is in almost all cases, practically all cases, accommodating the needs of these users improves the experience for all users, and I'll give a couple of examples of that. So unfortunately, these stats are for the US because they just have the best statistics, or at least the most easy to find statistics. But in the US alone, 21.2 million, or just about the population of Australia, 9.2% of the adult population of the US have some vision trouble. So the way that we can accommodate these users is to do things like avoiding low contrast text. And who has been annoyed at a website that has gray on white text? Right, so that is going to improve the experience for absolutely everybody, seriously. Avoiding relying on color alone for communication. So things like stoplight icons, which we've all seen, it's this is bad, this is maybe okay, this is good. But if that information is not communicated in any other way, then it's completely inaccessible to someone who is colorblind, which is quite a large proportion of the male population, actually. And also things like links, which are only distinguished from the other text by their color. If there's no underline or anything like that, then how is anyone who's colorblind going to know that that's a link? So as I mentioned earlier, making sure that text is resizable. So in terms of specifics in CSS, making sure that you don't specify font size in pixels. Providing text alternatives for visual media. So this is again for someone whose vision is so poor that they actually are unable to see images. All right, so again, in the US, 36.4 million people have at least one complex activity limitation. So these users may not be able to use a mouse or like may actually have trouble using a keyboard. So for these users, providing large click targets is absolutely critical. And I think, again, this is something that we all really appreciate. So my favorite example is this. You have a radio button. It's like a pretty straightforward thing that you use all the time. Like the other day I had to fill out my tax and they made this mistake, which absolutely drives me up the wall. So rendered it as a radio button, but you have to click on that thing. I don't know if anyone else has experienced the frustration of trying to deal with these things, especially when there's like 50 of them in a row, like you're doing a survey or something. It's so simple to fix. All you need to do is put a label on it, and then you get this click target instead. So this works well for regular users like me who just really hate fiddly interfaces. It works well for people who physically can't even hit a small click target. And it also helps for screen reader users because now that radio button is going to be labeled as option 2. All right, and this is something I'm going to come back to throughout this talk, but ensuring that your site can be used with the keyboard only is going to be really important for these users as well, because if you can't physically use a mouse or you can't use a mouse well to access something which is fine-grained, you're really going to have to be able to use the keyboard. And this is also going to help a lot with screen reader accessibility. All right, so I've been talking about screen readers a bit. So we have screen reader and Braille users. From the point of view of the web author, these are pretty much interchangeable groups. The way that they interact with the page is going to be somewhat different, but the way that you actually accommodate these users is pretty similar. These users may be blind, they may not be blind, they may have another impairment, dyslexia, they might have a learning impairment, they might get migraines and not be able to focus on text for a long amount of time. And the thing to remember about these users is if your site doesn't accommodate assistive technology properly, they will not be able to access it at all. So this is this site requires flash situation. It's just like, you can't come in here, this is not for you. All right, so screen readers. Essentially how a screen reader user is going to interact with a page on a computer, so as opposed to a mobile device. They will use the keyboard, so there'll be a series of fairly sophisticated keyboard commands. It's kind of like using your Vi or Emacs. You sort of get really, really good at learning key combinations that are going to allow them to interact with the page in a way that sort of approximates what someone might be doing with a mouse. So this example, you have the screen reader speaking that the screen reader is currently focused on a button which is labeled cancel. So it's saying cancel button. The user is saying, okay, go to the next thing. Then it's saying, okay, the next thing is a button called okay. And the user's saying, oh yes, please click that one. And then it's telling them that the button has been successfully clicked. So the reason it's saying button is that to a sighted user, it's going to be visually presented as a button. It's going to be obvious what the affordances are. To a screen reader user, this needs to be explicit. And this is something that I'll revisit a bit later on as well. But yeah, the important thing to remember is that you need to be explicit about what role things are playing. So I'm going to give a quick demo of a screen reader. All right, so this is like a very silly test site that I made. But I'm going to be demonstrating Chromevox, which is available as an extension for Chrome. It's built in on Chrome OS devices. If you are on GNOME, there's a built-in screen reader on that. There's built-in screen reader on OS X as well. And there's free screen reader options for Windows. And they'll all sort of feel a bit like this, even though you use them quite differently. So,
Happy place. Internal link visited.
All right, so I'm just going to go through the page a bit.
List with feed. Internal link list item.
So, okay, this is a bit weird. What's happening is that there's a menu here that is not visible to us, but which hasn't been properly hidden from the screen reader. So this is an accessibility problem.
Explore. .com/200/image.
We have another problem here, which is an image that doesn't have an alt tag. So it's reading out the actual file name of the image. So this is something that's actually really annoying.
Kitten McWhiskers. Complete profile.
All right, so I'm just going to click this button, and it's going to
enter
pull
dialog.
All right,
Chromevox is now inactive.
Turn off Chromevox so we can go back to what we were doing. All right. So that's like very, very quick introduction to what it's like using a screen reader. So the difference would be, firstly, if I were a full-time screen reader user, I would have the speech speed up much, much, much faster. You probably wouldn't be able to understand it. And secondly, I would be much more proficient at actually getting to where I want to go in the page. So I'm not, as a screen reader user, I'm not just going to like go through the page until I find what I want. There are a lot of shortcuts that you can use to find the content that's interesting. On a mobile device, just quickly as an overview, what tends to happen instead is, instead of using keyboard shortcuts, because obviously there's no keyboard, what you can do instead is actually explore with your finger on the screen, and it'll tell you what is actually under where you're touching right now, which means that obviously clicking or dragging, well, dragging is not really an option. Well, not quite true. Clicking and dragging are going to be a more sophisticated gesture. So they have to, instead of learning keyboard shortcuts, they're learning some specific gestures to perform those interactions. But essentially, it's going to sound a lot the same. It's going to speak a label and a role for each thing. It's going to give you feedback when you've actually successfully performed an interaction. All right, so that's what accessibility looks like. How do we go about actually creating that for our websites? Ideally, we start at the design process and start design with diverse users in mind. And as I keep saying, this is actually going to help everyone who's using the site. So having things like personas for these users is really helpful. Looking at how a keyboard-only user would interact with your app will help you make sure that that is all designed for and all implemented right from the start, and you don't have to go back and retrofit it. How would a screen reader user use your site? So thinking through the interactions. So if you have something like a drag and drop interaction or a hover interaction, that's going to be really difficult for a screen reader user to do. You need to think through those interactions and make sure there's an alternative. And how adaptable is your interface? So will it look okay? Does it even adapt to a mobile device for a start? Is it flexible enough to be spoken by a screen reader, or does it rely on subtle UI cues, things like that? Okay, so obviously there are a lot of things to consider, and luckily for us, there are actually some guidelines put down about what you actually need to consider. So especially if you're looking at things like governmental compliance laws, this is really where you need to be looking. So if you need to make sure you're absolutely covering all your bases, this is a good place to look. But honestly, it's pretty approachable, surprisingly. And I'm going to give some examples of the language from the Web Content Accessibility Guidelines. It's worth at least skimming over so you have an idea of what the concepts are. So it's organized around 4 principles, which is perceivable, operable, understandable, and robust, or POR, which, as my friend pointed out, is kind of an awkward acronym, but moving on. So perceivable implies that information user interface components must be presentable to users in ways they can perceive. So again, in the case of a screen reader, this means that you have to have text alternatives, things like that. Operable implies that you've thought through things like this hover interaction, making sure that people who can't use a mouse can still interact with that element. Understandable means that things aren't too opaque, things aren't completely incomprehensible to a user. And robust, so again, that it's flexible, it can be interpreted by a wide variety of user agents and assistive technologies. So addressing accessibility, as I keep saying, the first place to start is ensuring that you have a good keyboard-only user experience. So here are a few Web Content Accessibility Guidelines recommendations that address this. So making sure that it's all operable via the keyboard interface, sure, but also making sure that your focus order is sensible. And something that a lot of people seem to miss is making sure that focus is visible. So the easiest way to do this, where possible, is using standard HTML5 widgets. So the reason for this is that browsers will implement all of the accessibility for you by and large. And that is because browser vendors have to comply with accessibility requirements. B, it only needs to be implemented once in the browser. So if you're using something that has been implemented in the browser, that is going to be provided for you. If it is actually not possible to use HTML5 widgets, I should mention, you can style HTML5 widgets to look nicer, to look like what you want them to look like. You can apply CSS to things like buttons, radio buttons, and so on. All right. if you can't use HTML5 widgets because you're doing something that simply doesn't map onto a standard widget very well. User extend well-written custom elements. So there are a lot of custom widget libraries around these days, and a lot of them have put a lot of thought into accessibility. Again, because someone has had the need and contributed that back to the library, or it's been used by someone who's had to comply with a law. However, if you do come to writing your own custom elements, the first thing you need to do is make sure that you're using tab index to make sure that it is focusable. So obviously, if you can't actually get keyboard focus on an element, there's no way you're going to be able to interact with it using a keyboard shortcut or anything like that. Tab index is pretty straightforward. Presumably, you've all at least seen it before. The only slight complication is the different values that it can take. So tab index greater than 0 is going to be a manual tab order. So this is kind of a bit of a use at your own risk feature because you have to be very careful to make sure things stay in the right order when you're adding elements. All of those will come before anything with tab index 0, which is also slightly counterintuitive. But tab index equals 0 means it will just follow the natural DOM order of the page. Tab index -1 means that it can take keyboard focus, but you'll have to focus it programmatically. So that's not going to be in the tab order. You can't get to using the tab key. So this is for things like menu elements, where you want to be able to access it possibly using a keyboard shortcut, but not want to be able to tab to it, like we were on the demo site that I showed. All right. And another thing to keep in mind is whenever you have a click or a touch event that you're handling, because you're writing a custom element, make sure you handle keyboard events as well. So things like the enter key or the space key are common ones for activating elements. The easiest way to know which keyboard events to listen to is to follow established UX platforms, UX patterns, user experience patterns for each platform. So take a look at a native element on the platform that you're looking at, see what keyboard events it responds to, like how you naturally interact with it, and then copy that. There's also this best practices document as part of the ARIA spec, which I'll get to a bit later, that has a bunch of recommendations for different widgets for what keyboard events you should listen to. All right, so I'm coming back to this because it's quite important, making sure that the keyboard focus indicator is visible. So one thing a lot of designers seem to like to do is make focus really, really subtle or actually invisible. So here's a case where it's really, really subtle. Can anyone spot where focus actually is? It is in there. Well, you know. Anyone else? Can anyone not see it? Right. So it's actually there. It's very, very slightly darker. It's like, okay, yeah. So imagine you're trying to actually interact with this thing using the keyboard, and then you're like, wait a minute, what am I focused on? And you start hitting keys, and then all of a sudden you've navigated to a different site. And you're like, what just happened? So it's really, really irritating when people do this. All right, and so coming back to the Web Content Accessibility Guidelines recommendation again, focusable components receiving focus in an order that preserves meaning and operability. So obviously the best and easiest way to do this is to use a logical DOM order. So things like making sure that menu items are right after the button that activates the menu rather than right at the end of the DOM. Obviously, sometimes there are really critical reasons why it has to go somewhere else, and this is when you would use the tab index or using actually manually focusing things to ensure that the focus order is reasonable. Secondly, if you're showing a pop-up or a modal dialog, make sure that you move focus within the pop-up once it actually pops up. So call focus on something within the dialog, and move focus back to the element that triggered the pop-up so that your user can continue their flow once they're done with it. So we have this thing again. So I've clicked that thing that was almost invisibly focused, and this pop-up has appeared. So now the focus is there, which is good, except that it was actually completely invisible. There was no way to know that. So yeah, it's kind of half right there. Okay, so the next thing that you need to do is express the semantics of your interface. So the relevant recommendation here is information, structure, and relationships being conveyed through presentation can be programmatically determined or available in text. So when you're using assistive technology, it needs to be able to determine the structure of the page. So it can say this is a button, or this menu button controls this particular menu, things like that. So again, looking kind of familiar, using standard widgets or well-written custom elements wherever possible. If not, you're going to need to learn to use ARIA to express the semantics of your custom elements. So ARIA stands for Accessible Rich Internet Applications. It's a suite of roles, states, and properties that are expressed as HTML attributes. So here's an example of what we call div soup. So this is an interface that is expressed entirely in terms of divs and spans and has no semantic information in it whatsoever. So we have something which is presumably styled as a button. It looks all pretty. It's obvious to a sighted user what it's going to be doing. And it handles a click event. So ideally what we want to do instead is just make that into a button, and then it'll handle keyboard events pretty trivially, and it'll look right, it'll sound right to a screen reader. You can still style it as whatever pretty style your UX designer likes you to use. If we, for whatever reason, can't use an HTML5 element, we can use this role attribute, which is going to tell the screen reader that this is acting as a button. So that will be spoken as send button in our screen reader scenario. However, that really doesn't quite cut it because, as I mentioned earlier, you need to still make sure you handle keyboard events. So the role doesn't actually add anything magic to the user interface. All it does is make sure that the screen reader knows what role it's playing. So you still need to add a tab index, and you still need to handle the keyboard events. So obviously, it's starting to become clear why it's much, much easier to just use standard widgets wherever you can. And in fact, that's the first rule of ARIA use, as per the ARIA spec. If you can use a native HTML element or attribute with the semantics and behavior you already require built in, instead of repurposing an element and adding an ARIA role, state, or property to make it accessible, then do so. It's pretty straightforward. So what ARIA is actually doing, when you take a document object model, that will be transformed by the browser into what we call the accessibility tree, which is basically like a simplified version with some extra metadata for the screen reader to say exactly what things are. So in this case, you can see we have a label and an input, and that gets translated into just an input with an associated text label. So things like that. So what we see there is when you have a native element, that's going to get translated into an accessibility object which makes sense to a screen reader. It's going to have a role, it's going to have the relevant states that the screen reader is interested in for that element. When we have this div soup situation, it's going to come up as something completely useless. So something that is not obvious what affordances it has. It may not even be possible to use a screen reader to click this thing. But adding the role and adding this checked state means that it's going to show up as a checkbox, and it's going to say that it's not checked. So this is going to mean that the screen reader user can actually interact with that. Okay, so that's a bit of a really quick background on accessibility for anyone who sort of hasn't really done that much with it before. I'm going to look at how you actually test for it. So when we start manually testing accessibility and sort of exploring what accessibility our app has, first thing to do is kill the mouse. So like I said, addressing keyboard-only usability is going to get you a long way towards complete accessibility. So using the keyboard only checks for the structure of the DOM, so whether things are in a sensible tab order. It checks for focus management and also whether your focus is visible. And it's going to check for keyboard event handling on custom controls. However, it does not check for things like labels on images and controls, ARIA markup on custom controls. How are you going to know that just using a keyboard? It doesn't check for color contrast. So you may have great eyesight and you may not actually realize that something is too low contrast for someone with poorer eyesight than you, or maybe on a poorer monitor or something like that. It doesn't check for media alternatives, so things like subtitles on a video or transcripts, things like that. Okay, second step, just try it out with a screen reader. Obviously, you're not going to use it in the way that a full-time screen reader is going to, but it'll tell you if there are any showstoppers, if there are any places where you can't actually do an interaction with the screen reader that you really need to be able to do, for example. So there are a bunch of screen readers that are completely free to use. A bunch of them are free open source as well. I'll have a link at the end, some of those. But yeah, Chromevox, Orca, NVDA are all free and open source for desktop, and TalkBack is free and open source for Android phones. So that will help you find if you're missing labels on images and controls, if you're missing ARIA markup, or you've got bad ARIA markup, or if your keyboard navigation isn't working. It doesn't check for, again, color contrast or media alternatives. Plus, it's really slow, and it's kind of a very high noise way to check for accessibility problems. So once we get beyond the DIY manual testing and we're like, well, this is a bit inefficient, the gold standard is professional manual testing. So there are companies that have experts that will actually perform all this manual accessibility testing for you. They know exactly what they're looking for. They'll provide you a report with like where your compliance is at. And you know, if they've ticked it off, it's good to go. Pretty much anyone should be able to access it in theory. Unfortunately, firstly, it costs money, and that's all right if you have the budget for it. If like this is something you absolutely need to do for your company, great. You know, that's their job. It's fair to charge money for it. But the real downside is that it's difficult to do many iterations. It takes them time to go through and thoroughly test everything. And you know, if you have some showstopper bug in, say, the first opening screen of your application and they simply physically can't get beyond it, it's like, well, you've got to wait for them to send the report back saying we can't access 90% of your app, and then fix that and then send it back again. It all takes quite a bit of time. So finally, before I get to automatic testing, the most important thing you can do is talk to and listen to your users. So this is an example of someone at work that I work with saying, we've really done our best to try and do all the manual testing accessibility ourselves. We found a few bugs, we fixed them, but I really need someone who is a full-time screen reader user, or at least a very proficient screen reader user, to check this out for me and like double check, make sure we haven't missed anything. So if you have users that you can reach out to and ask them to do this, fabulous. Also, make sure your feedback mechanisms are accessible. This is something that I've seen missed in a lot of cases, and it's really frustrating to find an accessibility problem and then go to be like, please fix this problem. Help. And then once you get the feedback, really like listen to it, read it carefully, make sure that you're actually fixing things as you go. All right, so finally we come to automated accessibility testing. So there's a bunch of things that we can check with automated accessibility testing, including color contrast, whether you're using valid ARIA, states, properties, roles. So ARIA, like any sort of programming language, you really have to use it correctly in order for it to work at all. If you're using an ARIA role that doesn't exist, the screen reader is not going to know. You know, if you use like ARIA role equals check, it's going to be like, that's not a thing. I have no idea what to do with this. You may as well not have any ARIA there at all. Labels on images and controls, we can check whether an image has an alt tag, things like that. Clickable elements that aren't focusable. So this would represent something which is handling a click event but not handling a keyboard event, or at least not able to take keyboard focus, and a few other things. So what these have in common is that these are the simple bugs that can cause the worst user experiences. So this is where you have the thing like your start page doesn't have a label that distinguishes the OK button from the clear button. And so the user has maybe filled out all of their details and then can't tell whether a given button is going to completely just throw away all the work they just did or actually let them into the app. So essentially it's like this. Imagine you're a wheelchair user and you've been getting around just fine and you get to the place you're going and there's just a single step. And you're like, oh, come on. So close. So automated testing is a part of the whole picture. Obviously, it's not going to get you 100% of the way there. You still need to test things manually. There are still things that it can't find, but it can catch these low-hanging fruit issues. It can increase visibility if accessibility is a concern for developers. So if you have automated accessibility testing as part of your continuous integration and accessibility regressions make the build go red, people are going to start to take notice. And it can prevent some accessibility regression. So if you get your accessibility checking green, then something regresses, you're going to know about it. So it doesn't address usability. So it doesn't address things like having an interaction which is simply inaccessible, or like having something which is technically accessible but completely unusable because it's so complicated. It doesn't address all possible accessibility issues, so I'll get to a bit later that there are actually issues that it's impossible to check for automatically. And it doesn't mean you don't need to understand accessibility issues, unfortunately. You still need to be able to fix the issues when you find them. So I'm going to demonstrate this tool called Accessibility Developer Tools, which is available as a Chrome extension, also available as a library, which I'll just show in a minute, but I'll just show you the Chrome extension first of all. So back to this demo site. Inspect the page. Unfortunately, because this is so low resolution, it's going to look a little bit janky, but we'll do our best. So this is the Audits tab in Chrome Developer Tools, which probably a lot of you are familiar with. This is going to allow us to run this accessibility audit on the page. All right, so it's found quite a few problems with this page, which is not surprising given we actually saw problems when we looked at it with the screen reader. So for one thing, we've got an invalid ARIA state or property, which you can't really see there, but I'll take a look at it in the Elements panel. So it's showing up that we've got an ARIA value now, which is a valid ARIA property name, but it's got an invalid value. So it's trying to set it at 80%. And, oh no, okay. And we also have, all right, we have some low contrast text. So that's over here. So that element there. So we can also check that one out. Okay, this is actually my favorite feature, so I always like to demonstrate it. This will actually tell you what the contrast ratio of this piece of text is, but also tell you what values you can use to achieve AA and AAA contrast ratio ratings according to the Web Content Accessibility Guidelines. So, and I can actually apply that style on the page and say, okay, that's what it should look like for AA level, that's what it'll look like for AAA level. So that's very useful, I think. So that's just like very, very quick overview of what that tool will actually allow you to do. There's like a bunch more features. There's a bunch more rules. So those rules have come from looking at the Web Content Accessibility Guidelines. Yes?
Can I run that in CI? Can I run that in my CI?
Oh, yeah. Yep, I'll get to that in a minute.
Okay.
All right, so these, yes, so these have been seeded from reading through the Web Content Accessibility Guidelines and going, okay, what can we feasibly automatically check for? And then looking at other problems and other anti-patterns that we've seen sort of over time, just looking at things that have caused accessibility problems that look like we can say, okay, we can test for that. So here's 4 of the audit rules. There's a link at the bottom there to see the entire list of audit rules that are available. Currently there's 15. There's another one in a pull request currently. So the first one, the purpose of each link should be clear from the link text. So this is directly from the Web Content Accessibility Guidelines. Elements with ARIA roles must have all required attributes from that role. So this is from the ARIA spec. So there's like, as I said, there's like a right and a wrong way to use ARIA. If you use it the wrong way, it's not going to work. Role equals main should only appear on significant elements. So again, this is from the ARIA spec. We're talking more about the semantics of what the roles should be. And elements which are focusable should be visible on screen. So this was what I showed you when I was doing the screen reader demo. We have some elements which are not visible on the screen and yet show up to the screen reader, which is a real problem. It's very confusing when you have something which is, the UI is inconsistent. So I said I'd mention what we can't test for. So here's an example of what we can't test for. Information structure and relationships conveyed through presentation being programmatically determined or available in text, which is a bootstrap issue for us. So if you can't determine the structure programmatically, how can you know that it's there? How can you test for it? So this is a pattern that I see really quite a lot and that kind of bothers me. You have a div which is acting as a button and which has a click listener, but the click listener is applied at the body level. And the click listener then checks what the event target is. And there are some really legitimate reasons to do this. However, it does mean that we have no way of knowing as a screen reader or as a testing tool that this div is actually listening for click events and no way of knowing that it should also be listening for keyboard events. All right, non-text content. So looking at text alternatives that serve the equivalent purpose. So we can detect whether there's an alt tag, an alt text, but we can't detect if it's any good. So this is XKCD. And the alt text here says infinite scrolling, which, okay, it's valid alt text. It's really not doing the same thing as the image is doing. So interestingly enough, on the same page, there is this div with a transcript describing the image, transcribing the text of the image, and even showing the title text, which is phenomenally useful. And really, this should be the alt text or used in the described at tag. However, it's actually invisible to screen readers, which is incredibly ironic. All right, so yes, this is where we talk about running this in your CI. The extension that I showed you earlier is also available as a JavaScript library, so that same rule set. You can get it as a single file. However, unfortunately, you can't include this directly. You have to download it and serve it yourself because it's not on a CDN. If anyone wants to put it on a CDN, let me know. Awesome. Or you can get the uncompiled source. You can use it in your own projects from the GitHub repository there. I'll also link to that at the end. So you can also, if you want to just try it out, you can use it as a service at accesslint.com. So this is me running accesslint.com on linux.conf.au website. So there's a bunch of things that it's good at, and then if you scroll down the page, there's quite a few things that it's failing as well. Yeah?
Alice, do you know how it compares to the Wave toolbar?
I have looked at Wave toolbar. I think it should be fairly similar in terms of like what it covers. It's just, yeah, different in how you use it, I guess.
Can you repeat the question?
Oh yes. Can I comment on how it compares to Wave toolbar? So yeah, it's the difference is mainly that for the extension, it integrates into your DevTools workflow. And for the testing library, obviously you can use it in your continuous integration, use it like this. All right, so yeah, so to use the API, the easiest way to do it is to just simply put a script tag on your page with the testing library, put it after everything's loaded, obviously. Run the audit, so it's just axs.audit.run. And then you can create just a printout of the audit report using this axs.audit.create report with the results object that comes back. So just to quickly look at what you get back from that axs.audit.run call, you get an object like this. It'll tell you that for each of these objects is a result for a single rule. It'll tell you whether it's pass, fail, or not applicable. And it'll tell you if it's fail, any element that it's failed on. So these are just the actual element objects that link to the elements on your page. And then you can, so if you're using this in your own libraries, you can use this to create a custom report or to do something more interesting with. However, if you just use the default report that's built in, it looks like this. So this is what you would use probably in your CI. And it's going to display each element that failed the audit as a query selector that you can then run on your page and see the element that's failed. And one thing to mention is that you will also have a link to a wiki describing what actually the problem is. So that will help you get more information, understand better what's going on. You can also configure the audit. So for example, we might decide this elements with meaningful background image completely doesn't apply to me. This is only for sites that need to run in Firefox. I know my site only needs to run in Chromium. I'll just completely ignore that. You can also ignore particular selectors for a given rule. So say my UX designer is really just not playing ball on this contrast ratio thing. We've come to a compromise where we're allowed to have low contrast ratio text just on elements which are considered disabled. So I'm going to ignore selectors for that just so that my build can go green because I know about that issue. There's nothing I can do about it. You can set the scope. So say you have some site Chrome around the actual main content of your site, which is what's changing. You don't want to rerun the audit on the Chrome every single time. You can restrict it to just a single element. And you can override the severity of each rule. So each rule is either severe or warning. And this came about because one of the people I was working with wanted to set image without alt text to be severe because they had some compliance issues. They had to absolutely critically make sure that it was a build error if an image didn't have an alt text. So this library is used in the wild. Firstly, it's used in the Chromium project, which is why it exists. It's used on various Google properties as well. It's used by a site called casecommons.org, who've built the Capybara Accessible plugin, which is for the testing tool Capybara. It allows you to run this audit as part of your testing. And there's also a Jasmine matcher coming soon. That's also in a pull request. if you wanted to use it on your project and you're using Jasmine. If you're not, if you're using some other testing tool, then the library is right there. Go ahead and write your own custom matches for whatever your testing tool is. All right, so quickly, looking at actual strategies we can use. So first thing to decide is when are you going to run these audits. So in Chromium tests, so the way we're using it in Chromium is if you've ever looked at the Chromium settings pages or the new tab page and so on, that's all written in HTML. So we can use this tool on that, and we do. And the way that we run it is every test that we run, it is run on teardown. So whatever state you have in the page at that time, which hopefully you're testing as much of the UI as possible, it's going to run the audit on the state that your test has left the page in. You can also call a hook to run it manually during a test. So if you know that you've done something that's going to change the state of the UI, you can then run it then. Capybara Accessible takes a different approach. They run it every time the page loads, and then after every single click. So on the assumption that any click could actually change the state of the UI. Web Puppeteer forces you to run it in a separate test, just because it was too difficult to do it any other way. You can also use any combination of the above, obviously. So when you first run it, your accessibility audits will almost certainly fail, especially if you've never looked at accessibility before. So these errors are kind of like lint errors. They're going to provide you information about potential accessibility problems. It's worth going through each one. Often it'll be sort of a class of problems, so you don't need to look at every single element. You'll be able to make one CSS change and that'll fix it. And then go through and fix all these issues before you start running the audits as part of your CI. So then the next question is, how do we handle failures? And there's a couple of different options for this as well. So what we do in Chromium is we have, at the moment, every single UI test runs the audit during test teardown. And the audit results are printed as part of the test output, but there's a global setting, which means that by default, it's just printed out. It's just log spam. So if you're looking at the test output, you'll see it. If not, you won't notice it. But what we do is we go through, and once we fix those warnings, so we're going through test by test, page by page, fixing those warnings, and then flipping that flag so that if there are any regressions, it's going to make the build go red. And it does, and people yell at me, but it's their fault. All right. Capybara Accessible, as used by Case Commons, use this strategy. So what they did is they create a branch which lets them triage all of the accessibility audit failures. So they've just turned it on for everything. It's running after every click. It's going to print out a whole bunch of failures. They have to look at every single one before they can merge this branch, and then either fix that problem, or if it's too complex to fix or they need a bit longer to do it, they can tag that test as inaccessible, which makes the test pass, but you still have to wear the inaccessible badge of shame. So once they've actually finished that branch now, so they have merged that branch back into master. So from now on, the state is no new feature can go in with an inaccessible tag. So the time of inaccessible tags has run out, you can't add any more. And a team is going through and fixing those inaccessible tests. So over time, there will be no more inaccessible tags. All right, to sum up, accessibility is for everyone. It's for me under certain circumstances. It's for people who are temporarily disabled, people who are permanently disabled, people who are just in a hurry, people who don't like small click targets, and so on. There are a bunch of well-known practices for accessibility that are documented and pretty easy to find. Using standard HTML5 will make your life much easier. Do it. And automated testing can catch low-hanging fruit, catch regressions, and increase visibility of accessibility issues. And there are some links for you to copy down. These slides will be available as well, obviously.
Thank you very much, Alice.
Thank you.
We are over time.
Oh, sorry.
That's all right. Maybe one quick question if someone's got one.
Do you know anything from Python?
I don't. But I can help you. I can show you how this was written, and you can write one.
Yeah, that's kind of what I'm doing.
Yeah. What are the, I'm not a designer, so I tend to just go and grab one of the toolkits that lets me cheat. What are things like Bootstrap like for accessibility at the bottom?
So that demo site that I used was actually written in Bootstrap. It's pretty good. I mean, I think I would still recommend running an audit on it just to see where it stands. But yeah, in general, I found it's it's pretty good. I mean, I think Bootstrap by itself isn't the whole solution, right? So it'll be sort of something like Bootstrap and Angular, or Bootstrap and that one that I can't remember the name of right now. But yeah, in general, it's okay. Yeah, they've thought about it. All right.
Thank you very much.
Thank you.
Appreciate it.
Cheers.